Welcome to Study Loop.
For this problem, on the topic of waves and sound, we are told that at a given height above the surface of a freshwater lake, we generate a sound pulse, and we receive the echo from the bottom of the lake to the point of origin 0.11 seconds later. If we are given the air and water temperature, we want to calculate the depth of the lake. Now we know that traveling in a speed v in a material for a time t, the sound wave will travel a distance x that is given by x is equal to v times t. Now, in traveling from the point of origin to the bottom of the lake and back again, the sound in this problem travels through air and water, and this expression will apply to both materials. The total distance traveled through air is 2d air, and that's a distance of 10 meters. And the total distance traveled through water is 2d water, where d water is the depth of the lake. Now the travel time in air plus the travel time in water must equal the total given time of 0.11 seconds. So we know that twice the distance traveled in water for the original sound wave and the echo must equal to the speed of the wave in water times the time it takes to travel in the water, or the travel time in the water. So if we rearrange this, we can divide both sides by 2 and we get the distance traveled in water, or the depth of the water, is equal to the speed of sound in the water times the time that the wave takes in the water over 2. We'll call this equation 1. Now the total travel time in both materials is the time in air plus the time in water. And if we solve this expression for T water and substitute the result into equation 1, we get that the depth of the water is equal to the speed of sound in water, and we can replace the time in water as the total time T minus the time spent in the air, and this is all divided by 2. So we'll call this equation 2. Now the travel time in equation 2 can be obtained by remembering that the distance traveled through air, 2d air, is equal to v air times t air. Now we know the speed of sound in air, and so we get t air is 2d air divided by v air. So this equation can become the speed of sound in water, v water divided by 2, and we can replace t minus t air as the total time t minus 2 times the distance traveled in air divided by the speed of sound in air. Now, from this expression, we have all these values, and hence we can calculate the subscript water, or the depth of the lake. And this is equal to the speed of sound in water, which is 1,482 meters per second at 20 degrees Celsius, divided by 2, multiplied by the total time 0.11 seconds, minus twice the distance that the sound wave travels in air, which is 10 meters, divided by the speed of sound in air at 20 degrees Celsius, which is 343 meters per second. And if we calculate this, we get the depth of the lake, d, to be 38 meters.